your guys' thoughts as far as all of
Well, there you go.
Oops.
All right, folks, let's learn a little about ingestive behavior. I don't know if any of you have ever eaten something or had something to drink. Anybody in that category? No, I didn't think so, Scotty. That's all right. We're going to talk about ingestive behavior briefly, and then we'll move on to a few other interesting things. All right. A bunch of stuff we're going to skip over because I think it's, not that I don't think it's important, I think it's important for like another class, right? So you can calculate things. What does ingestive behavior mean? Just in case you didn't know how to pronounce ingestive, there it is for you. It's eating or drinking, right? So that's exciting. How many of you love homeostasis? Correct answer is everyone, right? Without it, you really have to spend a lot of time trying to like dial things in all the time, right? So why is homeostasis important here? We'll talk in a few moments about why that is. But what are we trying to do? Really with homeostasis, you're going for sort of like one target level, right? That's really all I want you to think about. You've got an optimal level of some measurement, and everything in your body, or at least that particular process, runs well at that temperature, at that pH, at that particular, osmolarity, whatever it is. You're always trying to go up or down to get to that set point, right? So if we were thinking about the homeostasis of this room, we might have decided a good set point was somewhere less than 10,000 degrees. And so we would hope that the thermostat would work, right? I think that's accurate. There's a brain. You guys have seen that before. We are going to spend some time hanging out down here in the hypothalamus. Lately we've been talking a lot about the hypothalamus. What have we talked about? When we talked about the hypothalamus, we talked about hormones, right? So we talked about that with the reproductive chapter. We talked about that when we talked about emotion. And we said a lot of hormones coming out of the hypothalamus kind of controlled that. So we're going to talk a little bit about hormones today as well for eating and drinking. Briefly, we should cover what's in a sort of a regulatory mechanism, right? This is pretty bare bones here. We're really just giving you boxes and putting words inside of it, right? You've got some variable, whatever that is. Maybe it's temperature. You've got some set point. I don't know what temperature you like to keep the inside of your house. 66 degrees is a good one. You've got a detector, thermostat, and you've got some correctional mechanism, your AC, right? So that's how this works. Most of the time in your body, we're running on something called a negative feedback loop. Okay. We talked briefly about negative feedback loops before, right? They work well. If you get too hot, what do you try to do? Cool down. If you get too cold, what do you try to do? Try to warm up, right? It's a pretty simple mechanism. There are positive feedback loops. There's like one. And we talked about this when we talked about the uterus, right? You guys remember the story with oxytocin and the uterus. The only time a positive feedback loop works is when there's a set endpoint, right, Natalie? If there's not a set endpoint, guess what happens? Things get out of control, right? If there's not a set endpoint on temperature, for example, you'll just continue to get hotter until, steam rolls out your ear and your brain melts. Keely, that can really happen to people. I just want to let you know. You ever wonder about that? What's the melting temperature of bone versus neural tissue to see if you could melt your... Nobody thinks about that. All right. I'll look that up on Google later.
It's really hot.
For bone?
Yeah, have you looked at the case of the solder children in West Virginia? No one knows what I'm talking about?
Can I say this just as a blanket statement? I don't really care about children anywhere or in West Virginia. so probably I didn't look at that.
Usually in a fire, the bones are left.
Right.
It takes such a high temperature to burn them up.
Right.
There was no bones left. There was no bones left in this fire that happened at this house in West Virginia. There were like 8 kids in the house. No teeth, no bones, no nothing.
Wow.
So they've never been found.
So here's what that was. Alien abduction. Saw it on the History Channel.
Just saying.
Actually, I think I misspelled alien.
Yeah.
There you go. All right, so positive feedback loops only work when there's a definite, like, hey, we're done. right? So you're trying to push out an infant. There you go. So negative feedback loops, we'll talk about that. We should also think about a satiety mechanism, right? This is kind of cool. How many of you have ever been thirsty? Yeah, it happens to people all the time, right? And what did you do when you were thirsty? Great job, Natalie. You just demonstrated what you do when you're thirsty. Okay? Something to drink. The interesting thing about this is, so why are you thirsty? Well, you're thirsty because your body fluids are down, right? There's some other things that might be going on. We'll talk about 2 different kinds of thirst later. End result's the same. When you get thirsty, you put some water back into your body, right? How long does it take? Like, so one reason you might decide you want to put water in your body is like the cells in your feet, right, might be kind of short on water, right? You get like, crinkled up and shriveled, right? Because they're short on fluids. Anybody know how long it takes water to get, like once you put it in your mouth, to get to your toes? It takes a while, right? A lot longer than it takes you to get that drink of water, okay? So that's what's interesting, right? So you're going to drink all that water, it's going to go into your stomach for a while, and then it's going to get absorbed and sent out to the rest of your body, right? But you stop drinking before the delivery of those nutrients, right? You do the same thing with food. You stop eating before that food actually reaches the parts of your body that might be using those those nutrients or those energy molecules, right? So you have to have some mechanism somewhere before that point that says, let's stop, right? It's kind of like, how many of you put gas in your car? I think most people do. Some people put other things in there, but I usually just recommend gas. So when you put gas in your car, there's a mechanism that like stops that, right? So you filled it up. You're not using that gas yet, right? It's not in the engine. It's not, because you're not supposed to like run your engine while you're filling up your gas tank, right? They tell you not to do that. So it's got a satiety mechanism. It's got a mechanism that kicks off the pump, right? It says, hey, we've got everything we need. We think this is going to work for a while. Let's get out and let's use those nutrients. Let's use those chemicals for whatever, and then come back and fill up later. Does that make sense to everybody? Awesome. Hey, there you go. That's an electric heater. And we just talked about this, right? You lose water. You realize you lose water because you've got some sensor inside your body, right? We'll talk about what those are. That says, hey, we're short on water. And they tell some brain circuits, drink water. You fill up your stomach, right? And then your stomach says, hey, I'm full, let's stop drinking. And that happens before that water gets absorbed back into your body fluids. Not a big deal. Some facts about fluid balance. Don't worry about this. You've got different fluids in your body. I don't think it's going to make a huge difference to you about what's going on. I do want to let you know there are 2 kinds of thirst, though. And what's really interesting about this is because there are 2 kinds of thirst, there are 2 sets of detectors, right, for thirst. And they're caused by slightly different things. The end result's going to be the same, right? It doesn't matter why you're thirsty, what that thirst is. The result's going to be the same, right? You're going to get something to drink. So, what about hypovolemia, right? What's that mean? Hypo means low. That means like volume, right? So you're losing some intravascular fluid. There are a couple of interesting ways you can lose intravascular fluid, right? Like a major hemorrhage. Okay, that's not the fun way to lose intravascular fluid, right? You want to try to avoid that. You can, of course, if you're losing a lot of body fluids, lose a lot of intravascular fluid, you can do a few things. Contract your muscles, slam down your veins and arteries. Hopefully you can kind of stem the loss there a little bit. But that's got some serious limits, right? If you keep losing body fluids, you're going to have to do something else. One of those things you're going to have to get a refill. Okay? We also have something called osmometric thirst. This guy's slightly different, right? This is changing osmotic pressure. I don't want you to think too much about this, right? Because I think when some people think about osmotic pressure and osmosis, they just, something doesn't work right. So don't worry too much about it. Basically what happens here, right, is the fluid between your cells and the fluid inside your cells are no longer in balance, right? Okay? And the fluid outside is a higher pressure than what's inside, which means what's inside has actually lost fluid, right? And so there's more fluid outside than what's inside. You need to get fluid in your cell. We'll just dump what's back in there, in that intracellular space. But the problem is, it doesn't work that way. Okay? So what you end up here with this is cellular dehydration. So instead of losing volume from your vascular system, we're losing volume from the cells, right? So they're two slightly different things. We're still losing body fluids. Okay? So that's a different sort of thirst mechanism. Now what's interesting is we actually have a couple of places, let's see. There you go. So, we're going to go back here in just a moment. But we have sort of two types of thirst, what we call volumetric and osmometric, right? So we kind of laid that framework down. I told you already we have two different brain regions. We have what's called the subfornical organ, which is looking for that volumetric thirst signal. And we have the OVLT, which is looking for that osmometric thirst signal, right? So we have two different detectors looking for two different things. So there you go. So again, volumetric thirst, we've got that, right? With volumetric thirst, there are some kidney hormones, right? We talked about hormones and so forth. There's some things going on in the kidneys, right? Angiotensin being one of those. Anybody heard of that before? This is a fun guy, does some cool things. It's going to constrict your blood vessels. That's great. And it's going to make you hold on to sodium and water. Okay? Sounds like fun. Now, under normal circumstances, this could be a real problem, right? What happens if your blood vessels are constricted and you're pumping more sodium in there? What happens when you pump sodium? Just as a real trick, water will always follow sodium, right? And so if you stick some sodium somewhere, water's going to go to it. So if you put more sodium in your blood supply, if you put more water in your blood supply and you've made that space smaller, what has happened that's probably a bad health outcome for you? High blood pressure, yeah, who was that? Scotty? Great job. So high blood pressure, right? So high blood pressure, not so good, right? However, if you're losing volume, right, if you're losing that blood volume, then trying to increase that blood pressure to maintain that at a normal level. So, does that make sense? And interestingly, it produces thirst, and the only like really specific appetite is the salt appetite, right? So I doubt that many folks have experienced that. I mean, you'd have to be pretty low on your volume to have like some severe salt appetite issues, right? But you can't have salt appetite, right? So you have some desire to eat some salt. And you think, well, that might be a bad idea, right? If I had like this real dry beef salt all the time, because again, high blood pressure. Salt used to be a very difficult thing, right? And by salt, I mean sodium. So sodium used to be a very difficult thing to try to get your hands on. These days, it's pretty easy, right? How many of you have like giant containers of salt at home? Yeah. I mean, lots of people do, right? It's pretty normal. Use it for different things, right? It's a good facial conditioner. I don't think that's true, but I can admit, exfoliates, I guess, right? Nobody's going to go home and rub their face in salt. Actually, one of you might, and if you do, let me know how that worked out. Jacob's thinking about it, right? Probably, yeah.
Just for you.
Yeah, I appreciate that. I really do. Really appreciate the effort you put in there. I got pulled out of the line at the airport once because I tried to bring some actual bath salts. Like actual bath salts. I want to be clear what I had, right? Because I tried to put some bath salts in my carry-on because I was thoroughly convinced it's not a liquid, right? I mean, if you've had bath salts, you know they're not a liquid. According to the TSA, they are. They failed basic, science class in the 3rd grade. They didn't quite understand solid liquid gas. It's like salt, it's a solid, right there. They're like, no, you gotta check your bag.
Oh, they think peanut butter is an aerosol too.
Peanut butter is an aerosol? It's the best kind of peanut butter. Put it right there in the aerosol can, spray it in just like cheese whiz.
Yeah.
Yeah, no, that was, but I will tell you this, the lady pulled me out of line And then so I had to like, she wouldn't even let me pull my own luggage, right? She had to wheel my luggage herself. All these people are looking at me as I'm walking by, like, what did that guy try to bring on the plane? I'm like, it's bath salts. It was a gift from my wife. I was traveling, I was bringing something back. Otherwise, it's a little strange that I have like bath salts, right? And then she brings me back, and what's even worse, she brings me back to the front of the line, so I cut in front of all these people again, right? And I know they're just thinking, Brandon, they're letting that crazy guy on the plane. I mean, what did he have in his bag? I don't know. I also got pulled out of line once for soy candles. I got bringing some soy candles back from San Diego once. They won't let you have that as a carry-on. Just let you know. All right. This is osmoreceptor business. I don't want you to think too much about it. Okay? What I do want you to think about is something called circumventricular organs. Okay? I've already told you about two circumventricular organs. How many of you remember the subfornical organ and the OVLT? I just said it like 45 seconds ago, right? So I'm assuming most of you can remember this. What does it mean to be circumventricular, right? So in the past, we've talked about something really awesome called the blood-brain barrier. You guys remember that? And what do we say about the blood-brain barrier? It's a barrier between the blood and your brain, right? And so it really protects your brain from toxic things, protects your brain from certain things. Now there are obviously chemicals that we ingest on a regular basis that bypass that blood-brain barrier, right? We've talked about any psychoactive compound that you might take, right? Something that's medication to treat depression, alcohol, for example, right? Anything that's going to change your sort of brain function or behavior is likely going to pass through that blood-brain barrier. The problem is if you are looking for, right? If I'm looking for something in the blood, right? Because that's where these kidney hormones are, right? Talked about this guy, angiotensin. That's going to be in your blood, right? If we want to look at, if we think about osmometric sort of issues, right? We're looking for solutes. We're looking for things that are going to be out there, right? All of that's going to be in the blood supply. If we put those detectors in your brain, and we put them on the other side of the blood-brain barrier, right? These hormones and these other signals, these other things that we're trying to detect are not going to get through the blood-brain barrier, right? So there are a few places in your brain where the blood-brain barrier is very weak. We talked about one of those called the area postrema, right? It's for projectile vomiting. It's everyone's favorite pastime. No? Nobody loves projectile vomiting? I find that surprising, Casey, right? Do you?
I like
Not being poisoned? Yeah, I guess, right. We'll see. So, projectile vomiting. That's one place. The other two places, again, subfornical organ and the OVLT, right? Because these guys need to have direct access to the blood to make certain what's in there. Is that telling us we're thirsty? Okay. How many of you recognize that ingesting the proper amount of fluid is important for your continued existence? Okay. I thought that was obvious, but just want to go back. Make sure we're there. Okay. Don't worry about this too much, but we already said because that doesn't cross the blood-brain barrier, we have to have those circumventricular organs. Now, both of these guys, the OVLT and I don't know how I misspelled OVLT. The OVLT and the subfornical organ both send information over to the median preoperative release. Okay, this guy is not on the outside of the blood-brain barrier. In fact, it's behind the blood-brain barrier where everything should be. Right. This is where your brain tissue belongs. It's protected, right? But it's got to receive those signals from outside. So we put two guys out there, right? Okay, they're exposed. That's fine. They're small pieces of your brain. Not a big deal. Everything else is going to be behind. So here you go. There's your blood-brain barrier on either side, right? Totally protecting your median preoptic nucleus, and of course the rest of your brain. While your subcortical organ and the OVLT are on the outside of that blood-brain barrier, right? So they can detect either those solutes or the angiotensin. Does that work for everybody? It's not so bad, right? All right, so that's sort of drinking. What about eating, right? We are literally what we eat. That's exciting to think about, right? People always say you are what you eat, but we are quite literally what we eat. We take those molecules, either from plant or animal, and we incorporate those into our bodies, right? That's kind of how this process works. You ingest something, whether that's a donut or a sweet potato, right? And you turn that into part of your body. And you use that. So there are sort of two things that you're going to do with those molecules. You'll either make or maintain, your organs and body parts, or you'll use the molecules you ingest for energy. Right? So you can move around and you can sort of maintain your normal body temperature. Okay? Not a big deal. Here's a real important point. I don't think anybody thought about this. Fuel comes from your digestive tract, right? So you're going to eat food. That's going to sit in your digestive tract for a while. Anybody know how long it takes food from start to finish? Nobody? Anybody want to take a guess?
30 hours?
30 hours? That's pretty good. Most of the time they say 24 to 48, right? It's going to vary from person to person. There's a great way you can find out how long it takes your particular digestive system to get things in and out, right? There are things called marker foods, right? Anybody? Nobody knows about marker foods. You know about marker foods. Yeah, Autumn.
These beets ones?
Beets.
Is it?
Beets, oh man, beets are kind of interesting. Beets are supposed to be really good for you, right? Anybody eat beets on a regular basis? Anybody thought they were like dying the first time they ate beets? Because things that come out of your body that are not normally red were red, right? And you go and you're like, that's not good. And then you spend a long time on Google, like typing in different combinations of where blood can be coming from certain spots blood shouldn't be coming from, and then you remember what you had for dinner last night, and you're like, oh man, it's beets. Yeah, so beets could work, right? Beets might be a little difficult because you're really, I think, you're trying to look at something subjective there, right? Because there are varying shades of exit material, right? And sometimes it borders more on the red than the brown, right? That happens from time to time. But if you have like a high contrast food you could eat, right? That's going to be a definite like, yes, it's there, or no, it's not. And something like corn is a great example, right? And you can really track your digestive system with corn. You guys should do this. I mean, this is like all jokes aside, because you need to know, right? Like on a regular basis, like, are things moving like they should? And if they're not, then you got to check and see if there's an obstruction. Just don't think about this stuff. You're like in the second decade of your life, and you're just going to assume my colon's going to work this way the rest of my life, and it's not, right? Talk to your parents, right? How many of your parents are giving you the call, yep, Dad's going in for his colonoscopy tomorrow? Anybody had that one recently? Yeah, right? It happens all the time, right? I'm like, I didn't want to know that. Well, what if something happens to your dad? Well, you can tell me after. You don't have to tell me before. I was like, I don't need to know. Right? Just keep that to yourself. It's between you and your doctor. So, but you really should try to keep a track on that. But what's important from that story, aside from just general colon health, is you're constantly using energy, right? Even when you're asleep, you're using energy because your heart's still going, you've still got metabolic processes going on, you're still breathing, lots of stuff's happening. We already talked about all that stuff in your brain that happens while you're sleeping, right? I mean, that's heavy on the metabolic process. Where are you getting these nutrients, this fuel from while you're asleep, right? You're not getting it from the food you're immediately cramming down your throat, right? Because most people, you don't have like a, now I'm thinking about aerosol peanut butter, right? And how easy that would be to like hook up a machine to squirt peanut butter in your mouth like every 15 minutes in the middle of the night.
Yeah, it's slow.
Yes, it would be like a glob would come out and you kind of have to chew it while you're asleep. My brother used to fall asleep eating, like when he was like, you know, a year old or something. He would like eat, might fall asleep and just continue to chew. Kind of a weird thing. So, fuel comes from the digestive tract. Stuff's going to hang out in there for a while. Put something in, it's going to hang in your stomach for a few hours. Then it's going to start moving through your intestines and moving out somewhere else, right? So here you go. We've got different things we call fasting and absorptive states, right? So fasting is any time you're not eating, right? Anytime you are eating, that's your absorptive phase, right? So you're actually actively putting food into your body. You're going to try to pull those nutrients out. Now, if we're pulling those nutrients out, we got to do something with them, right? Okay, what are we going to do with them? We're going to store them, right? There are some great places you can store that extra energy. How many of you guys have ever heard of like insulin, right? You always hear about like blood sugar and things like that, right? The cool thing about insulin is it takes glucose and it turns that into this sort of complicated thing called glycogen. It's not complicated for you to really think about, it's just complicated in its structure. It's just complex carbohydrate. Basically that's just a storage molecule. Later you can come along and just clip off little pieces of glucose as you need to with this other enzyme called glucagon, right? You can make that happen. If you're sort of short on insulin, I mean, why would we give someone who's diabetic insulin? Well, if their insulin's not working, guess what happens? All that glucose never gets converted into some long-term storage molecule, and it's just like hanging out there in their blood supply, right? That sounds exciting, right? And then eventually it'll come out in their urine, and you can have some sweet tasting urine that way. It's a true story, right? Thankfully now they have other ways you can test for diabetes besides drinking someone's urine.
This is the second time I've heard this today.
Yeah, it's important, right? You guys got to think about what's in your urine, right? You got to check the stuff that comes out of your body. It's related to what you put in your body, right? Yeah. You can get savory urine too if you have high blood pressure, because it'll have extra protein in it. So there you go. Don't want that savory urine either. You just want it nice and salty. Just a little bit of bitter aftertaste. That's when you know you're in the right category. What are some other sort of long-term reservoirs, right? So you can put things into these like fatty acids, so adipose tissue, right? So we can stick stuff in the liver, and we can put these long-term reservoirs in adipose tissue as well, right? And then we'll draw from that later. Right? That's kind of an awesome thing, right? It's kind of a cool thing. Now, as our sort of environment has changed, there are some occasional problems with this, like storage process and our food intake, right, and our activity. And so there's like a combination of factors. We'll talk a little bit later about sort of some rise in obesity rates and things, why that's a real challenge. I mean, you're lucky it's a challenge, right, for us as a species. If it wasn't, we probably wouldn't have survived all of those like lean years before we invented, you know, TV dinners or whatever. I don't know. I'm just thinking of random things that I see at the grocery store now. So before we had easy access to food, we had to be able to take whatever nutrients we had, be efficient about what we were using, and then store the rest of those, because we don't know the next time we're going to come up on, like, you know, berries or roots to chew on, or a rabbit that we might happen to be able to catch, right? Whatever that is. So. Now, most folks, at least, I'm going to make a little bit of an assumption here, because there are folks who are food insecure, but most folks have sort of ready access to food, right? It's something pretty easy that you guys can get access to. All right, we already talked about those things. Awesome. And here's a fun diagram, right? Talking about the different sort of things that you might eat. Glucose, fats, and amino acids, right? Different things you might do for that. What's interesting is your brain sort of runs exclusively on glucose, right? This is why Fun Dip is so wonderful, right? This is why people love candies and sugary items, right? Because we need that for our brains to work. So that's really something that we're constantly striving for. But before the invention of Dunkin' Donuts, we didn't really have ready access to that, right? So it wasn't like a major problem. Hey, this guy's cool. What about ghrelin? Anybody heard of that peptide before? It's kind of cool. This actually comes out of your stomach, and it's a nice signal to your brain. It's also produced by some neurons in your brain to let your brain know, hey, your stomach's full or your stomach's empty. We don't need you to eat, or we do need you to eat, right? So what's kind of cool about this is if you were to chart someone's ghrelin levels over the course of a day, right? And what you would see is a spike in ghrelin, and these are the times when that individual eats, right? So as that ghrelin increases, right, it's going to send a signal to your brain, hey, your stomach's empty. It's probably time you put something in there if you can. We want to kind of keep that nutrient train going, right? We want to constantly be putting things in so we can store those long-term molecules. We don't know for long-term storage sources. We don't know when we're going to be able to get that again. So we're going to kind of have that going for us. What I think is interesting is this kind of final peak there toward the end. What's like the number one way people always say, like, oh, if you want to lose weight, just stop eating late at night. I don't know who thought, I mean, I don't know. That's an interesting concept, right? If you want to lose weight, you can just stop eating in the middle of the day too, I assume. Right? As long as you eat less, I think you would lose weight. I mean, I think that's how that works. Well, I got a slide on that in a minute, Brandon, just hang in there. But what I think is interesting is, you know, there's that spike late in the day too. How many of you have ever tried to lose weight by not eating late at night? You don't have to raise your hands on that. And how many of you have found that difficult to do, right? We had a chapter a few weeks ago on sleep, and one of those things that makes you sleepy is when you're full, right? When you're sated. If you're hungry, it's hard to go to sleep, right? And the reason for that is, if you go to bed too hungry, guess what happens? You die, right? Imagine you've got 3 hours of nutrients left in your body to survive, and you don't have your alarm set to wake you up, but for another 8 hours. There's 5 hours there of you just kind of, you know, rotting corpse situation, right? So you've got to think about that. So you don't want to go to sleep hungry, because if you don't wake up, you're a goner. So that's why I always like to take a chocolate bar to bed with me. You never know, Billy. I mean, just be prepared, right? You never know when somebody's going to break into your house, and you're going to have to, I got to down this protein bar quickly, so I can scare them out of my house. I just don't think about these things. If everybody had you think about this, you know, if everybody had a protein bar in their bed, right? How much better would life be? Don't worry about that. And your liver is kind of an important guy, because there are detectors in your liver for glucose and for lipids. We're talking about fats there. If they get low on glucose or fats, your liver is going to send signals to your brain like, hey, it's probably time to eat. Your brain doesn't really have receptors for other molecules other than glucose, but your brain has glucose detectors. Again, if your glucose levels drop, your brain goes, hey, have you thought about going to Sheetz? They've got Snickers. And so you'll head over there, and hopefully, you're not so glucose deprived, you actually start buying the wine in the cups. Because if you get to that point, you're making those bad decisions, there's no hope for you. I can see on your faces how many of you have purchased the wine in the cups at Sheetz. Do they sell that here in town? Has anybody seen that, or is that just me? They do? Okay,
like little chalices.
Yeah, it's like but it's on like a cardboard stand.
Super scary.
It's weird, right? I mean, just it's like the strangest thing. I mean, it really is. Like I'm gonna go get like some Sheetz sandwich and a glass of wine. I don't know. I don't understand it. It's whatever. Part of it, I'm not a wine drinker in general, so, you know. So if you guys are thinking about giving me an end of semester gift, don't make it wine. Because your grade will just do this. It'll sour just like those grapes. I'm sorry?
We'll have to send out a new poll then.
A new poll? Yeah, you'd already taken up a collection. Yeah, that's right. So, you should have known the first thing you tried wasn't going to be good enough anyway. So here you go, Brandon. Secret here, regulation of body weight. Balance your food intake with your energy expenditure. If you like the weight you are, keep eating as much as you have been and doing the same stuff all the time. If you don't like your weight, you want to make it higher, you want to make it lower, then Change your food intake or your energy level. It's that simple, right? So there you go. I mean, I go to the store and I see all these like weight loss books. I mean, you don't need them. Right here, one bullet point. I saw them for you. All right. Not a big deal. Don't worry about those things. And don't worry about this. But this does happen to folks. How many times have you not been hungry and then all of a sudden you smell something and you're like, well, I'm definitely hungry now. It happens, right? That's part of the idea. I mean, part of the idea is you need to take advantage of opportunities as they come along, right? Because again, we evolved in an environment where, you know, we weren't eating lunch every day at noon, right? We didn't have this regularity. We weren't able to get, you know, these like, you know, frequent Subway cards and get the little punches on them, right? Every time we go in and get a sub and you get 10 and then you get a freebie or whatever, I don't know. Right? So we had to take advantage of opportunities that came along. So if you were just like walking down the road and all of a sudden there's a rabbit, right, with a broken leg and I think I can catch it, well, you should probably just go ahead and grab it and try to eat it, right? And I recommend you do this now. Just walk up and down the street for rabbits with broken legs. Great food source. Oh, what about this guy, CCK? This is kind of cool, right? If you have fats, right, down in your small intestine, you're going to go, hey, let's shoot out this hormone CCK, and you feel full, right? Like I'm done eating. That seems good. So then the idea was like, well, why don't we just give people, like, if you want to lose weight, why don't we just give you like a CCK shot, right? That seems like makes a lot of sense. The problem is eating's very complicated, right? And you don't think it's very complicated, but it is. The neural mechanisms behind this, the metabolic mechanisms behind this, everything that you've got built into this is complicated. The reason for that is eating is essential to your survival, right? And so you don't want only one system to make that work, right? You want multiple backup systems, right? You want multiple pieces of that puzzle, so if something fails, there will be other things that can pick up the slack. Aspirin and you'll still eat, right? I mean, that's what's important, okay? So CCK is one component, but it's not like the only component that makes it work. It's actually a study several years ago with rats, and they actually blocked their CCK, right? And so they thought, well, definitely if we block CCK on these rats, guess what's going to happen? They're just going to continue to eat, right? And there are a number of rat models for eating. What was really interesting is they found that these rats where they block CCK, they actually didn't gain any weight at all, right? They're like, well, completely, blows our hypothesis out of the water. Megan, what was really interesting is they forgot to like monitor how long the rats spent on the running wheel, and the rats who had their CCK blocked actually spent more time on the running wheel, so they maintained their weight by increasing their energy expenditure, right? They were increasing their food intake as well, but they increased their energy expenditure accordingly. Once they removed the running wheel from the cages of those rats with the blocked CCK, their body weight went up accordingly as expected. All right, there's a fun feature.
Did they gain weight because they were sad because they didn't exercise? They were like emotionally eating? They didn't get to
I don't know. You should do that as a follow-up. Yeah, you should like measure serotonin levels or something in these rats.
If I can find a rat with a broken leg, I can catch all.
Yeah. Speaking of rats with broken legs, when I was in graduate school, there was a guy who made wheelchairs for rats. He was studying spinal cord injury and recovery models and stuff, and so he had these but he actually found that the rats without the wheelchairs actually recovered faster, right? Because they were like actually trying to like send signals down to their hind limbs, and they were more likely to recover. So there you go. I don't know. There you go, right? I mean, we've already said put stuff in front of blind people as they're walking down the street. Now we're taking wheelchairs from people. Yeah, this is if you're gonna, I don't know, because you're gonna go out in the world and just be wonderful do-gooders, right? Let's not worry about that crap. That's not a big deal. Hey, what stops a meal? That's interesting. Usually it's the check is what stops the meal. But in case that doesn't stop you, there's some other things, right, that will. A lot of that's going to be at the liver, right? So finally, your liver is like really the first organ to receive nutrients, right? It's kind of that first organ right out of your intestines, right? It's going to get these nutrients, and that'll send some signals up to your brain. Says, okay, time to stop. Not a big deal. All right, we already talked about insulin receptors. Oh, hey, who remembers that story about leptin, right? And we said leptin controlled kisspeptin, and kisspeptin starts puberty, right? So we're coming back briefly to this leptin story. Leptin comes from adipose tissue, right? So as you have more adipose tissue, you're going to have more leptin, increases kisspeptin, and that will start your fun thing called puberty a little bit sooner, right? Worry about force feeding. So this is one of those mouse models, right? This is what they call the OB mouse. So they had a strain of mice that are prone to gain weight, right? And actually what they did in this particular model, actually really interesting. This guy, they just let him eat whatever he wanted. This guy, they let him eat, but they also gave him shots of leptin, right? Okay. And when they gave him shots of leptin, so what they did here is they knocked out leptin, right? So no leptin here. But when they gave this guy shots of leptin, his body weight sort of maintained at a normal mouse rate. So there you go. Brainstem. Obviously, if you cut your brainstem off, bad things happen. But there are some important connections here that control muscles for eating and drinking. And if you sever those connections, then rats will actually cause some problems. Let's see. I don't want you to think too much about this. There are different parts of the hypothalamus. Some of those are responsible for stimulating feeding, and some of them are responsible for inhibiting feeding, right? Don't worry about this either. We talked briefly about obesity already, right? There have been some definite environmental changes, physical factors. I don't know, anybody ever calculated their BMI score? Yeah, it's probably not. I don't know. There's a lot of conflict on that, right? I wouldn't worry about it too much. Just try to be healthy. And problem is, like, trying to treat obesity is like a real trick, right? Part of the problem is there are some folks who actually think about overeating as a form of addiction. It's really sort of interesting because some of the same brain mechanisms are involved, right? And if you're addicted to something like cocaine, what's a great way to stop is typically to remove yourself from the environment where you use cocaine, right? That's one of the first things they always say is don't go back where you're getting these cues, right, that are going to have you turn back to that drug. The real problem with that, with eating, is you got to eat. You got to eat, Brandon. I mean, right? You don't have to do cocaine, but you do have to eat, right? That's something you have to do. And so there's no way to get out of the environment where you're eating, because that's just wherever you happen to be, you're going to eat. So that's one reason it becomes a very, very complicated thing. It's I don't know, it's just kind of an interesting thing to think about. About pharmacological intervention. Don't worry too much about this stuff. Awesome. Computer froze. This is your tuition dollars at work. You guys excited about the 3.5% increase in tuition next year? That's a real conversation starter. Casey, how much is it going up for you guys? You don't want to know. Because grad students pay a little bit more, right?
We just accept it.
Just accept it. Yeah. hey, at least it's not like, what was it? What was it, like 2 years ago or a year ago? It went up 10%, 9%, something like that. Just, they raised it just as much as they could without getting the state to approve. Because if they raise your tuition too much, they have to get state approval, right? So it's like, bring it, you know, just bring it right up under that, right? That's like when you put it in the bunker instead of try to get it over the water hazard. Anybody watched anything on Sunday, you know, put it in the bunker. That's how you win a jacket. Nobody a Tiger Woods fan? That's fine. Somebody as Keely is, I don't know why, that's fine. Yeah, I mean, it was more of a like, he just didn't lose, right? It wasn't so much that he played like this incredible round of golf, but everybody else was like, whoa, water, wonder if my ball floats, and they don't. And he was like, I've played long enough to know they don't float, so I'm just gonna put it in the sand. Still impressive. Still impressive. Right? I mean, at 43, after not winning anything for over a decade, to come back and pull something off like this.
Yeah, his best round since 05.
Since 05, yeah. Yeah, I mean, yeah, it's, I mean, I don't think he's got another one in him, but we'll see. All right, and we should briefly talk about, we talked about sort of one thing, we should briefly talk about other eating disorders, right? I don't want to spend a whole lot of time on this. Mostly what I would really like to say to you is, if you or someone you know is dealing with an eating disorder, Casey, where can they go for help? To the clinic. We have a resource for you, right? I do think there's an interesting sort of shift recently with, what do they call it if it's not like more males are being diagnosed with eating disorders, is what I'm trying to say, right? So there's other, and then there's like body dysmorphic sort of issues, right? So it's not just about trying to go in one direction, but maybe going in the other. All right, questions about that? Comments, concerns?